One of the most reliable ways to deploy application to AWS is through Elastic Container Service using Fargate technology. Why it's reliable and how to use it, I'm going to show you in this video right now. Hi, my name is Yuri Kuzemko and I'm helping people to better understand and easily learn technologies and software development on practice. Make sure to stick to the end of this video where I show you the example of Terraform infrastructure as a code with the AWS Elastic Container Service Fargate deployment infrastructure. So AWS Fargate is a serverless compute engine that allows deploying application without managing servers and paying only for the resources utilized. AWS Fargate brings a lot of flexibility and reliability to our deployment infrastructure because we can particularly deploy any kind of application to the Fargate. We just need to pack it into the Docker container. Furthermore, AWS will take care of managing all of their servers and everything, and we just can focus on building our application and make sure that it is reliable by default. The AWS Fargate available for Elastic Container Service and Elastic Kubernetes Service. The difference between Elastic Container Service and Elastic Kubernetes Service that Elastic Container Service is a pure AWS solution, so it's built by AWS and supported completely by AWS. But Elastic Kubernetes Service is just the managed solution of the Kubernetes open source cluster orchestrator. If we consider these solutions from the pricing point of view, the Elastic Kubernetes deployment will charge us around $80 a month for just managing our clusters. And this is on top of the fee that we need to pay for the Fargate technology. On the other hand, the Elastic Container Service will charge us only for the utilized resources provided by the Fargate technology. In this tutorial, we're going to be covering Elastic Container Service only. But if you're interested in learning more about how to configure and deploy Elastic Kubernetes Service, let me know in the comment section below and I will prepare another tutorial video for it. So let's get started. So let's start off deploying our AWS Elastic Container Service using Fargate technology. And we're going to deploy the HTTP server, so it means that we need to be able to externally access this server with HTTP protocol. So in order to do it, the first thing we need to create is our Elastic Container Registry repository. And you can just search by ECR in your AWS console search. Click the Elastic Container Registry. And you can just get started, create a repository. Then you can name it. I will name it microservice. And you can leave all the parameters by default. Then you can click create the repository. And this is the Elastic Container Service repository where we're going to push our Docker images. And let's go ahead and push some image just for demo purposes. I just found this dummy image in Docker Hub. I'll go ahead to my console and pull this image and then push it back to AWS. I just executed this docker tag command in order to tag the image I've pulled from Docker Hub with the tag from Elastic Container Repository Service I've just created. And you can get this tag by copying it from the AWS console. And then you can run the command like this, where you specify your region, the profile if you're using multiple AWS CLI profiles, and then Docker login, and then you should specify the address of your Elastic Container Registry bar with our repository. And this command will let you log in your Docker local Docker host to the AWS ECR repository. And now we can just run docker push and then go ahead and copy these repository name, and now we're pushing the image. So it's pushed now. We can go here and just double check. Yes, we can see that we have a latest image. So once we created the Elastic Container Registry, we can now go to our Elastic Container Service. We can just type ECS in Google search and create all the stuff we need to create there. So Elastic Container Service has its own entity definition. Here is a diagram that describes how it works. So basically, the core thing of your Elastic Container Service compute power is container definition. This is actually just a JSON specification of your Docker configuration that AWS ECS will execute. And then you have the task definition. It's an abstraction on top of the container definition. And task is kind of like a logical element of your application, because one task can have multiple containers, but the task is something that's responsible for allocating resources per task and managing these tasks and managing the container instances. So the other abstraction on top of the task is the service. And service is something that has some configuration or logic about how tasks are executed. So for instance, we want to run the task every time we get a new HTTP request, or we want to run a task every time a new message added to queue, or we want to run a task as a cron job periodically. So this is something we configure it on the service level. And also on the service level, we configure all the network configuration for the task, like the subnets the task will be executed into, and all of the information like this. And the other top level of AWS Elastic Container Service is Cluster. And Cluster is just the logical element on top of everything. We group all the definitions into the cluster. So let's say when we have the one cluster with our backend services that contains different tasks and container definition services, and we have another cluster with our monitoring systems where we're running some self-hosted monitoring systems. So this is just no more than a logical way to group our items, our applications in the cluster. So we can create cluster over there, but let's start with creating the task definition. So I'll click create new task definition. And then over here it's important that we choose Fargate. So we're gonna be using the AWS Serverless Managed Solution, not the EC2 one, where we need to manage virtual machines by ourselves. So we're choosing Fargate. Then task definition name, I would call it microservice. Then we choose Fargate. So here we'll need to specify the task role. I'm gonna click over here to create this role in IAM console. And I just choose the AWS service role for ECS, then click create role over here. Then AWS service, then here we enter the ECS Elastic Container Service. So Elastic Container Service Task, and then permission policies, and search ECS in this search field. Just type in ECS and click enter, and then you should find the Amazon ECS Stack Execution Role Policy. Choose this one, click next. Then role name, I would say microservice ECS task. And here you go. Then click create role. The role is going to be created. Now it's created. So here we need to refresh the page, and we choose the microservice ECS task. It's as default here, which is Linux. Then we can start with the least amount of resources right now. Here we click add container. Container name, I will name it service. And then here we need to specify our ECR image, and to do it we will need to go to our ECR repository and copy the image URI from here and paste it here. Okay, so we don't need to click this one. We can skip all of these, and then port mappings, web mappings, we just can, let's see what port they're setting in 8080 port, so we can use the same 8080 port over here. It's gonna be TCP. Then the command health check, we can add the health check command as well. I'll skip it right now, but here you can just define the command that will run some kind of, they might approach our HTTP server to just set up the health check. You can set up the health check over here. It's really not relevant for us right now. And then we can skip all of these. Yes, and then we can skip all of these and click add. And we have the service added. Hey, by the way, here you can add the environment variables you want. So for instance, if you need to add some credentials to your service, you can add them through the environment variables. So here, like some value. Yeah, you can also use this value from expression, but yeah, I would suggest you just use the some value and click update, and then you just click the create, and now we have the task definition created. So now we can go to our clusters and create the cluster, networking only. Then next step, Then we can name it as backend. So our cluster is created now. We can click View Cluster. And then here on the cluster, we can create a new service. In the launch type, we choose Fargate. We'll leave it by default for Linux. Task definition microservice. The task definition we just created. Platform version latest, cluster backend, service name. We can call it service. Doesn't matter number of tasks. We can put 1, minimum healthy %. Okay, so deployment time rolling update, we'll leave it by default. Okay, so yeah, now we click the next step. We just use the default VPC. We can choose all the subnets from the VPC. So our task can be executed in any subnet we want. And now we can choose a load balancer type. We need to choose application load balancer and health check rate period. Keep it. And for now, we don't have load balancer yet, so we need just to click this button and go ahead and create our load balancer. So here we click create application load balancer. Load balancer name, I call it backend. Then internet facing, we leave all of these by default. The VPC, the mappings. We select all the availability zones. Then security group. There is a default security group, but we might want to create the new security group. Just click the create new security group over here. And in the security group, we're just specifying the policy, like how the service can be accessed. And let's call it backend load balancer. So the VPC, and then here we can limit it, like custom TCP and set port range. So they can only access the 80 port. Let's say we want to allow them 80 port, and we also 443. So we're allowing them, and then we're allowing anywhere. So we're allowing incoming connection to come only to port 80 and 443, and outgoing connection to come anywhere. And then we can click create. Okay, we need to add the description. I'll do the same as the name just for the demo purposes. We just created the security group. So we can go back to load balancer, refresh this field, and choose our security group. So we can control the network, how our load balancer can be accessed. So we don't want our load balancer to be accessed by any kind of 22 port or anything like that. We just allow only TCP ports like 18, 443 for HTTP connection. And now we use the protocol 80. So now we're going to create a target group and choose the IP addresses here. Target group name, let's call it microservice. Let's choose address 8080 over here. So we all of these by default, the health check, everything, click next. The IP address, port, so we have everything set up properly. So just click create target group. And then over here, let's refresh it and use this target group. And then we can go ahead and click create load balancer. Cool, so now we have our load balancer created. We go back to our ECS setup and then refresh it. And we just choose the backend load balancer, and the container we just added it to load balancer, add to load balancer, target group name, let's choose our target group microservice. Yes, we just choose the group we just created, and that's it. So we click next step. And then we can click configure service autoscaling to adjust service design count. So let's say we want to have minimum number of tasks is 0, design number of tasks is 1, and then we want to limit, let's say we don't want to have more than 10 instances of our application running to not have high cost of our service utilization. And then we have the target tracking over here. And then we can enter the policy, let's say CPU utilization. So in target value we specify 80, so it means that whenever the CPU reach 80% of utilization, we should perform scale out. And click the next step, and then we can go down and click create service. So now it's creating. So now we just click view service, and our service is created. There is another important thing we need to do once we created our ECS service. We need to scroll down and open our security group. And here in the security group of our microservice, we need to make sure that our inbound rules accept the connection to the port we've specified. Right now we have only port 8080 exposed, so I would choose here custom TCP and specified port 8080 because by default it's 80 and it means that we won't be able to access our service. So we need to change it to the port our container is exposed and then click Save Rules. Our task is still in pending mode. We can go ahead and refresh the page until it reads running. Okay, now it's running, and we can just click the task ID over here, and then we find the public IP address. We can copy this address and try to access it by the port 8080. And here we can see that our service is running successfully. That's good news. So now we can go to our load balancer. In our load balancer page, we can go ahead and click target groups just to make sure that our microservice target group works well. And it's still unhealthy, so it still takes some time to initialize it. We might want to wait for a while until the service is going to be initialized. Okay, now after we wait some time and our service is initialized, we can see that our load balancer here on the target groups. Our load balancer target group have the healthy target, so it's a good sign. It means that load balancer is successfully connected to our ECS service. So we can now go to the load balancer and actually try to reach out to it through the HTTP. And once you enter it, your server should give the response. But as far as our load balancer is not initialized right now, it will take some time to AWS to set up to 5 minutes, and then you will be able to see that your AWS service hosted that way. So here we can basically see the map of the AWS resources we just created. This map is a bit of more extended than the steps we went through. So basically we created the AWS ECS task definition, then we've created our ECS service for our microservice, right? This service by default had security group. We've created the task definition for our security group. We've added the CloudWatch log group. Then we can also add the CloudWatch log group to our ECS task definition if you want to see the logs from the CloudWatch log console. Then we added auto-scaling policy, so our services auto-scale based on CPU. And we've created ECR repository where our task definition pull triggers our container to pull repository from. Then we created the load balancer. The load balancer has linked security group where we adjust the rule to the ports we want to access. Also, we can link the Amazon certificate management service to our load balancer to manage our TLS certificates. We didn't do it in the video, but this diagram just show you for your reference. And we created the load balancer listener rule that has the target group of that we created the load balancer target group microservice, and then our service is connected to the target group. And all these resources are connected to AWS Virtual Private Cloud. We didn't set up this cloud because once you create AWS account, this cloud is set up by default, so we use default one. The idea is that our AWS application load balancer exposed outside, it accepts the HTTP request, and then through the listener rule, through the management, through the target group, it connects to our ECS task Docker container that serves the request. So this is the basic idea of how it works. So now if you talk from the cost point of view, we are really flexible over here because AWS Fargate charges us only for the resources utilized like CPU and RAM. And as far as we running Fargate, we can scale down to 0. So we managed to set up right now in our service level that the minimum amount of tasks running is 1, but we can actually specify 0. So it means that once we don't have any HTTP requests, our services are scaled down to 0. It's not recommended for the production environments, but it might be recommended for the development environments where you don't want to pay for the resources you don't use. And when our traffic grows, our ECS task will scale automatically. And here on this page, you can find the Fargate pricing calculator, and you can see that they're charging you per VPC per hour, per gigabyte RAM per hour, and thus you can calculate how much money you should pay depending on the resource you chose during creating the Fargate service. And if it comes to the load balancer, we also need to pay for the load balancer. And here the pricing policy for the application load balancer. So basically it charges you a minimum this amount per application load balancer hours. We can calculate it, and it's around $16 per load balancer per month, even if you not use it. So here you won't benefit from serverless because you still need to pay per hour for the load balancer, and you additionally pay if you overutilize the network resources of the load balancer. But still, it's not a huge amount of money in comparison for what benefits you're getting from this self-managed infrastructure over here. And as I mentioned at the beginning of this video, I'm gonna share with you the infrastructure as a code Terraform solution of our AWS Elastic Container Service Fargate setup. So basically all the setup we just did using AWS UI console are coded in this Terraform infrastructure, and you can find in this GitHub gist, and I'm gonna share you the link in the description section below to this video. If you have any troubles with AWS setup or want to learn more about different ways to deploy applications to AWS, just let me know in the comment section below and I create another tutorial video for you. If you like this video, click the like button, and if you're new here, make sure to subscribe to my channel to be aware about all the new tutorials on AWS, DevOps, and software development. Thanks for watching. I'm looking forward to seeing you in one of my next videos.